In this video, we're going to talk about how to add resistors in series and in parallel. So we already know at this point that resistors basically resist the flow of charge through it. And what's happening inside a resistor is the charges are flowing through and they're interacting with the material inside the resistor, and it's causing the energy that the charges had to be dissipated as heat, right? So when I hook a resistor up to a power source, you can see that when I turn the power on, the resistor gets hotter because what's happening is as those charges move through, they're interacting with the material inside the resistor and it's dissipating that energy as heat. So the resistor heats up, turns the energy from the electrons moving through into heat. So let's look at how to add resistors, because the way you add resistors in a circuit are going to determine how the circuit behaves, and you can change the values in the circuit just by putting resistors in different orders. So the first way we're going to look at adding resistors is the easy way, and that's in series. So in two resistors that are in series, all the charge going through one resistor must go through the other. That's the key here, must, right? So I'm going to draw two circuits and you can tell me if they're series or not. Okay, so here's some sets of resistors. Are A and B in series? Well, all charge that goes through A must go through B, right? So let's follow the way when I look at these, the way I do is pretend here's a little electron. I want to see what's going to happen, right? So here's this electron. This electron has to go through A. But see how it gets to here? And it could go through B, yes, but it doesn't have to go through B, right? It could go this way. So these two are not in series. Even though, yes, a charge could go from A to B, they're not in series because it has the option of going over here. This one is in series, right? Because here's a little electron, right? This electron goes, it has to go through here, and then it has to go through A, and then it has to go through B, right? So these are in series. So resistors in series are really intuitive. They basically just add up, right? So you can look at this two ways. There's the math way. You can say the equivalent resistance is equal to the sum to I of just each one, right? So Ri. Or that's the math way of saying it, right? You may see it that way. Or basically the equivalent resistance is equal to R1 plus R2 plus whatever, all the way up to Ri, right? So let me show you an example. If I have a circuit that looks like this, here's battery, and I've got three resistors in series. And let's say they're all 3 ohms. What's the equivalent resistance of this circuit, right? Well, because they're all in series, I just add them up, right? 3 plus 3 plus 3 is 9. I don't need to write that. So the equivalent resistance here is 9 ohms. Really easy, just add them up, right? And so the way to think of this, what's happening here is imagine blowing air through a straw, right? If I take air and I blow it through a straw, like you can try this at home, right? Get some straws, go to Whataburger, steal some. Take a straw, blow through it, and see how hard it is to exhale all your air out. And then take a second straw, right? And stick it in, kind of fold it up and put it in like this, so now you got a longer straw, and try the same thing. And you'll notice that it takes you longer to empty your lungs through the 2 straws than it did with the 1 straw. This is an analogy for what's happening with resistors. When you put them in a line, increases the resistance. Okay, so adding resistors in parallel is a little counterintuitive, right? If series was easy, if you can remember series is easy and just add them, then parallel is just the opposite of that. And this is going to come into play when we talk about capacitors too. So let's think about resistors in parallel. In parallel, what's actually going to happen is as you add resistors in parallel, the total resistance goes down. That seems like it shouldn't make any sense, right? Because a resistor slows charge, right? So why would that make the resistance go down of the circuit? Well, what's happening is you try the straws again, okay? So again, how hard it is to empty your lungs through 1 straw. Now what's going to happen if I put a second straw in parallel and do that? If you try it this way, try it with 1 and then try it with 2 that are parallel to each other, and you'll notice immediately it's easier to breathe through this, right? Same concept. You've opened up more paths for charge to go through, right? So if here's 1 resistor here, if I open up another branch over here and add a resistor like that for it to go through, it's like opening another door in a room. If I have a room full of people and I have 1 door, everybody's got to file out through the 1. But I'll get more people out of the room faster if I open up a second door. Same concept. Charge has more paths to go through, so it increases the current because the charge is able to move easier, even though you've added a resistor. All right, the rule for 2 resistors to be parallel is that both of their terminals must be attached to the same node. Okay, so here's some examples. So first off, what's a node? A node is basically a part of a circuit with no resistors or batteries or anything in it. So basically, like on this one, here is a node right here. All of this thing right here is a node because there's nothing in it, right? It's just a wire. Basically, anywhere it's just a wire, that's a node. So let's look at these 3 and decide if A and B are parallel in each one. So pause the video and predict whether you think A and B are parallel in each of these. Okay, so let's look at this first one. Remember, in order to be parallel, both terminals must be attached to the same node. So in this one, even though it may not look like they're parallel right next to each other, these are in fact parallel because here's a node here, right? A and B, their ends both touch that node. And then here's a node here, and the end of A touches it and the end of B touches it. So those two are parallel. How about this one? This one is also parallel because here's a node here and here's a node here. Right? A touches here, B touches here, right? These two ends are basically connected. They touch here, so they're connected here. It doesn't matter that this one is over here because these two are parallel. How about this third one, right? So this one is good. This third one, a lot of people get confused on this. This one, they're not parallel. Even though those two are across from each other, right? This one is in the way. So here, they both touch, right? They both touch this node. But over here, this node for A touches this other resistor. They're not directly connected. So this one, they're not parallel. The equation for parallel resistors is similar to series, except everything is the reciprocal. So we can say the equivalent resistance, the reciprocal of that equivalent resistance, is equal to the sum of all the reciprocals, right? Or the other way you might see it sometimes is REQ to the minus 1 equals R1 to the minus 1 plus R2 to the minus 1 plus whatever to Ri to the minus 1, right? So you're doing the same thing. You're adding everything up, but you're adding reciprocals. So let's do a couple examples. Okay, so here's a circuit, and I have three 3-ohm resistors all in parallel with each other, right? So here's a node down here, and here's a node up here. See how they all touch each other? So these are all parallel. I've already decided that. So I'm going to add the reciprocals, right? So in this case, if I'm doing it, my equivalent resistance, reciprocal, is equal to 3 to the minus 1 plus 3 to the minus 1 plus 3 to the minus 1, right? And so if I do that, that's equal to a third plus a third plus a third. So that's the reciprocal of the equivalent, right? So I need to get rid of that reciprocal by taking the reciprocal of this at the end. This is the thing a lot of people forget. Once you add those up, you have to take the reciprocal again to get rid of it over here. So a third plus a third plus a third is 1, right? So that equals 1, and the reciprocal of 1 is 1, right? So the answer is 1 ohm. So this equivalent resistance is 1 ohm. That was dumb. That was easy. Let's do a little bit harder one. All right, so how about this one? Now I've got a 2 ohm, a 4 ohm, and a 10 ohm resistor all in parallel with each other. So again, I'm just going to add the reciprocals. So reciprocal of 2 is 0.5 plus the reciprocal of 4 is 0.25, right? And you can do this in your calculator. The easy thing to do is just type it in like this in your calculator, but I mean, these are easy ones. And the reciprocal of 10 is 0.1. So my REQ to the minus 1 is equal to all of this. But again, you can't just add those up and stop there, right? So this equals 0.85. You can't just stop there. This is where everybody messes up. You can't just say that's your answer. You have to take the reciprocal again to get rid of it over here because this adds up to the reciprocal of the equivalent resistance, right? So now I have to take the reciprocal of 0.85 to give me just the equivalent resistance. And that comes out to, I think it's 1.18 ohms, right? So the key with series and parallel resistors, if you can remember the definition and the math for series equations, then parallel is easy because series is the one where they just add up. So if you can remember how resistors add in series, you know when you see resistors in parallel, you have to remember that reciprocal rule, and then it becomes really easy.